Hello, welcome everyone to our SNOMED-CT web series. This is our SNOMED-CT research webinar. Thank you all for joining today. We're all used to Zoom webinars at this point, but just a little bit of housekeeping. Reminder that everyone is currently muted and your video is disabled. But if you have any questions as we go ahead and place your questions in the Q&A box at the bottom of your screen. At the end of today's presentation, we actually have ample time for answering questions, and we'd love to get into some nice dialogue. So be ready for questions, but you can post them even as they come up during the middle of the session, and we'll answer those at the end. Today's session is being recorded. The recording will be available on our SNOMED-CT, SNOMED International YouTube channel, which I'll talk about in just a few moments. And we'll also make sure to have these slides available to you as well. So I mentioned that today's webinar is a SNOMED-CT research webinar, but we have a whole web series, which include clinical webinars, implementation webinars, and we also have a podcast. So I encourage you all to go to SNOMED.org/web series and also check out our podcast. And learn more about SNOMED-CT in these various aspects, anywhere from clinical to implementation to research webinars. We've been holding these for a number of years now, so we have a nice library of community webinars in our stack. And as I alluded to, we have a SNOMED International YouTube channel where all of our videos are posted. You'll also find posted videos from our previous SNOMED expos through the years. I encourage you to go ahead and like and subscribe to the channel. You'll find a playlist of all the SNOMED-CT research webinars. So if you're really keen to know more about research done on SNOMED-CT or with SNOMED-CT, I encourage you to go and check out that playlist. And for those who want to be notified of upcoming research webinars or other SNOMED-CT research-related news, I encourage you to join our SNOMED-CT research reference group. This is just a Google group where I push notification out to you maybe once a month or once every other month. It's not going to clog up your inbox, I promise. But this is a great way to join and just be notified when we have these research webinars. And also, if you're interested in getting the recordings and you're not able to sign up, while you'll get the recording information, if you register, if you join the research reference group, I'll also send you the link via there. So to join that, you just have to email me, sro@snomed.org, to join. And I wanted to do a quick announcement for SNOMED-CT in Europe. This is a 2-day conference in Brussels and online. This is going to be held May 22nd and 23rd, again in Brussels or online. And you can see that we have a packed agenda where we're going to talk a lot about semantic interoperability in and across Europe, current activities in Europe, and also current initiatives across the EU and all of Europe on not just SNOMED-CT, but also across health data interoperability. It should be a really great conference, and I encourage you all to register and go in person if you can, but if not, definitely register to attend online. More information on that can be found at snomed.org/SNOMED-CT in Europe. You can see the URL up in the corner there, or you can also just email me and I can get you the link, no problem. And also, we're really excited, as always, for our annual SNOMED-CT Expo. This year, it's going to be October 24 and 25 in Seoul, Korea. Right now, the abstracts are being collected for the expo. So the expo abstract closes on April 24th, so we highly encourage you to get your abstracts in. Last year was highly competitive, so get your abstracts in, and we are exploring ways to showcase additional community member support and showcases of SNOMED. So go ahead and get your abstracts in. We'd love to see you at Seoul, Korea in October. And I'm going to wrap up my speaking. I don't know if I ever said I'm Susie Roy from SNOMED International, and I host our web series, our research webinars. There we go. But I am very much welcoming to all of you, and would like to welcome Dr. Vincenzo Limperio. So a little bit about Dr. Limperio. He is an assistant professor of pathology at the University of Milano-Bicocca. His activity is focused on favoring the progressive implementation of digital pathology in the routine of practice, from pre-analytical phase to the application of artificial intelligence tools to assist in diagnosis. The research stemming from this effort is centered on the adoption of these innovative methods for the characterization of ontological and non-ontological diseases. The recent interest in the systematization of pathology archives involves the harmonization of reports, whose retrospective narrative nature limits interoperability and case retrieval for both clinical and research purposes. To address this, the application of natural language processing techniques showed promising results on the automatic extraction of SNOMED-CT codes from pathology report archives. So we're really excited to hear more about this. And Dr. Limperio, please go ahead and proceed.
Thank you, Susie. I am very happy to be invited and to speak about this topic that saw me and my group involved in the last 2 years. The topic we are talking about is the application of natural language processing techniques to assign almost automatically SNOMED-CT codes, but it can be applied to other types of codes, to pathology reports that, as we pathologists well know, are mainly narrative, meaning that they are not structured yet in the majority of the realities. I do not have big conflicts to disclose on this topic, but I have to disclose that I am a pathologist, meaning that, as you will see from my presentation, everything is mainly centered on the clinical needs that we encounter day by day, from the diagnostic point of view, but also from the clinical research. To address this, let me do a little bit of background, because this project on the automatic assignment of SNOMED-CT codes inserts in a bigger picture, in a bigger frame of the attempt of digitization of our laboratories. I come from Italy. I work in Italy, in north of Italy, in the city of Monza, that is really close to Milan. Probably many of you already know it for the Formula 1 circuit. The region in which Monza and Milan are is the Lombardy region, that has different centers, big hospitals with their pathology department. And in these years, we are trying to create a network. This one that you see is the network for NGS analysis of the non-small cell lung cancer. At the same way, and this has been just created in 2023, in the same way we are trying to create a network of digital pathology that can connect all these realities. And this actually is a stony way, because the majority of our laboratories are still analog. We discussed this at the European level within the European Society of Digital and Integrative Pathology. We try to dissect the workflow of a pathology department that is still largely, unfortunately, analog, and to transform this analog workflow into a digital workflow, different steps have to be undertaken. And so we did this within the Lombardy region. We tried with a survey to understand what's the current situation of the pathology laboratories in our region in the north of Italy. What we did, for example, is concentrating to the archives, that are archives of blogs and slides, but also archives, of course, of pathology reports. These are the preliminary results of the survey that we are going to publishing. As you can see, the reporting and archiving processes are still largely not automated or only partially automated, meaning that both archiving and reporting are still mainly manually done, especially the archiving by pathologists and pathology technicians. Regarding the archiving and the reporting, the process that we are going to start of digitization of the pathology departments are taking into account the different modifications in the workflow, both for reporting and archives. Archives are the current interested topic in our departments, because currently they are mainly manual. They suffer of environmental variabilities. These are the situation in which the pathology departments are, not only, of course, in our region, but in many realities. What we want to avoid is this kind of mess, because they can become troublesome when you have to retrieve material for molecular studies, consultation, research, because all these things can be not tracked. The pathology world that we want and that the patients deserve is a pathology world that is completely tracked. For the physical archives of tissue slides and blocks, coming to, of course, what is the main focus of our journey today, the pathology reports. This is the current situation. What we want to adopt, and we are going to transmit this to the Italian pathology departments, absorbing the European guidelines, is to concentrate and order and track all the slides and all the blocks that we collect in our pathology departments. And at the same time, this is due to the obtainance of digital slides on which we can do primary diagnosis, which is the final aim of all these things. So we are focusing to reorganize our archives to make them more efficient, faster, and secure also for the final outcomes of the patient. And as I mentioned, all this is done to make digital pathology a reality also for primary diagnosis. But once we have WSI digitized, and we can do the diagnosis directly on our digital slide, and we know that the archives are fine, the next step, of course, is reporting. But as you can see, the report, although it is in Italian, but maybe some of you already learned some words and understand some words of these reports. The reports that comes from this WSI are still completely narrative, meaning that I can report the disease in my way, and my colleague on the other side of the nation or the other side of the country can still report the same kind of disease with different words in a different way. So it's an half win for us. So we arrived to reorganize all the workflow until the WSI, but we still have some missing parts here in the final goal. So the next step would be to transform this kind of archiving and this kind of reporting. This one is space consuming, old style archiving of pathology reports. This one is a completely disorganized way of reporting things that can be handwritten or can be even digitized, but still narrative, because I can report things on my way. What the society is trying to do in Italy is to adopt a way of standardize and label also the diagnosis that we render on this last phase. So the report can be still narrative eventually, but we need to put labels, codes to these reports for different reasons, because this can improve the clinical management of the single patient, because in a way that we can take track of the different steps that the patient follow during his staying in the hospital or during his clinical pathway. For population, because once we have the coded diagnosis, once we have the coded reports, we can extract more information in a more efficient way that can have an impact on the outcome considerations for the general population on statistical and epidemiological level. And finally, of course, for research, because once we have clinical diagnosis labeled, if we think about rare diseases that are correctly labeled, this would enhance also our extraction of the data for retro or prospective trials and research. These are more or less the things that we can take as benefits from the adequate coding of our pathology reports, the standardization, but what we are more focused at the beginning in this digital pathology transition are the last two. Organize better the digital archives in a way that we, from the time we introduce this digital pathology workflow, we are able also to organize better our digital reports. And this, of course, can translate to a new way we face the WSI, the morphological diagnosis that we render at the microscope. Because once the case is labeled in one way, we can also improve the image interpretation, the case interpretation from an histological point of view. In this setting, the Italian Society of Anatomic Pathology is pushing towards the adoption of digital structured reports, acquiring the ICCR recommendation on different cancer subtypes. We are going to translate every single template of the ICCR. It is a huge effort from the society and from the president of the society, Dr. Filippo Fraggetta, and the future president, Professor Deitos, to transform these English structured reports from the ICCR into structured reports in Italian that can be included in our laboratory information system. So once we have even a structured report, the benefit of all the benefits that I exposed before can be effectively evaluated and used only if the codes, this kind of labels, are put next to the structured or narrative report that we have. And in this setting, SNOMED-CT codes is one of the most widely employed in the medical setting, and at least in Italy, in the pathology setting. There have been attempts to adopt alternative coding systems, especially locally organized in 2010 in the pathology domain, but currently the one that is most widely applied is the SNOMED-CT coding system. This can have lots of potential benefits and pro because it's multilingual, it's already employed by many countries worldwide, as a correspondence to international standards, can allow the interchange of information between the local LIS and the electronic health records of the same patient. All these benefits have been during the years faced by some limitations of the adoption of this SNOMED-CT code. Some of the limitations are the number of codes available. I'm talking mainly about the pathology domains, and for the pathology domain, one of the main source of reluctance in the systematic employment of SNOMED-CT on the reports has been the different types of code available for single cases. We can have morphological codes, procedural codes, topography codes, diagnostic codes. What has been the final results of the adoption of this heterogeneity of codes? That at the end, the pathologists mainly employed morphological codes for their reports, even if for example, topographical, procedural, or diagnostic codes would apply as well. So in the routine practice, one of the limitations of the application of SNOMED-CT, at least for the Italian experience, has been that at the practical side, mainly morphological codes, or at least only few of the adapt codes were effectively applied on the pathological record. And this is reported also from international experiences, because as you can see, only 2% of codes are currently used in the pathology lab from the SNOMED series. And there are different reasons for this. There are some redundant codes. There could be some manual errors that limits the adoption of these codes in the routine practice. Sometimes are not well integrated within the LIS, so they are not particularly user-friendly when we are diagnosing our case. And always for the same reason, because it's not user-friendly, it can be time-consuming, and also because of the multiple different codes that can be adopted in a single report. That being time-consuming can bring the pathologists to use just one code, like the morphological one. So from the pathology side and the pathology point of view, this can be quite a jungle to districate within morphological, topographical, procedural codes. And this brought to the 2010 attempt in the 2010 of College of American Pathologists to restrict the available SNOMED codes to the pathology subset, meaning all the codes. There has been this effort by the American Pathologist College to restrict the number of codes of interest for pathology. But as you can see in this paper of 2012 of Marcial Garcia Rocco and Arvidas, this attempt has been partly used because of the same reason that I mentioned before, because the pathologists currently tended to use always the same codes, mainly morphological, and also because sometimes basic pathology diagnoses were not present in this list of codes. And this was the situation of 2010 that at the time limited a little bit the systematic adoption of SNOMED-CT codes on our pathology reports. What has been the solution that we found in the last years to face these challenges in the adoption of the SNOMED-CT code? Informatics, statistics came to give us a help as pathologists, as clinicians, and to improve the coding process of our pathology reports. So one of the examples has been in a natural language processing. That is mainly the application of either machine learning techniques or deep learning techniques, which goes under the large head of artificial intelligence tools, to transform our language, current language, human language terms into computer science information that can be used either to standardize, schematize this language information, or eventually, as we will see, understand what's behind the human language and report the solution in the same human language, processing the information. Can be quite complex. There are models that are more easy and, of course, older than the newest one. I will take you in a journey towards this fascinating field of application of natural language processing in the field of coding. One of the most recent experiences published in Journal of Pathology Informatics adopt the natural language processing to extract information from the pathology reports. This is a nice experience, not strictly related to coding, but this is the first step, extracting the information from the narrative reports. In this case, for example, this study uses the XML structure of the pathology reports, adopting a sort of searching in the different section of the report of the main information that are then tabled. And once they are tabled, the authors were able to extract specific information from one disease in dedicated research once all the information from the narrative reports were tabled following the previous step of natural language processing. This is still not at the stage of coding, but this is the first attempt to extract specific information from narrative report using natural language processing. Coming back to the archives, what we face in our digital pathology transition as a difficulty is the retrieval and the time allocation of the storage of our blocks and slides archives. In this journal of clinical pathology paper of last year showed how you can move from complex archive in which you do not know how long to store and where to store blocks and slides. And the solution that these authors found is the adoption of SNOMED-CT, topography, and M morphology codes to understand when and where to store these blocks and slides. Because based on the morphology and topography codes combined one together, they were able to stratify the importance of the samples that has to be stored locally because they had a more high probability to be easily retrieved within days, or some more less prioritized specimens that could be stored in a more long-term situation because they do not have the probability to be retrieved in the short time. So in this case, the adoption of SNOMED-T and M combination showed a promising role in the stratification of the so-called hot and cold storing of slides and blocks. Another possible limit of our report is the differences, of course, in languages, because even if we do the structured report of ICCR, if I use my Italian language in my reports, it will be not understandable by Turkish or Chinese or Korean people, or even Spanish people if they read it in Italian. So the SNOMED coding is a little bit covering. In general, the coding and the SNOMED coding is in a way covering this heterogeneity in terms of languages, because the SNOMED code can be applied independently from the type of language. Once I code the report with that disease or that morphology or topography, it can be understood from different countries. Natural language processing can be used to assign codes independently from the language and eventually also translate those codes also to those languages in which they are not adopted yet. As you can see, natural language processing in publications and in biology is rising, and is rising in the PubMed publication and Medline publication in the last 20 years in different languages. So the availability of machine learning and deep learning models to transform our natural language into informations is really twisting the biology research of different languages. And this is the example again of SNOMED-CT adoption, because this is a paper from the Basque Country in which they adopted natural language processing to translate the concepts that stands behind the SNOMED-CT codes, because the SNOMED-CT codes are adopted for Catalan and for Spanish, but not for Basque yet. And they tried to see how natural language processing was able to help them translate the concepts that stands behind these codes. And they reached a quite good first results of 20% of success in translating the concepts behind, for example, diagnosing or disorder code. Less successful was for example, the procedural codes. But this is just an idea of what natural language processing can do in harmonizing the coding of the different languages, even if they are quite restricted to small countries. Another thing that can do natural language processing techniques is trying to transform, to convert codes from one system to another. For example, there could be the case of the translation of SNOMED codes to ICD codes or vice versa. This is particularly the case of oncological disease. If you look at this paper, again, from an Italian group from the institution, from the National Tumor Institute of Milan, they tried to adopt similar models that we used in our work that I'm going to show you in a retrospective series of pathology reports narrative to try to translate the narrative information that are relying in the pathology report into ICD oncology codes. And actually, this is something that is quite close to our experience, but with SNOMED-CT codes, the results based on this F1 score are quite good in the automatic assignment of ICD codes to pathology reports. I am arriving to the finish of the previous experiences in adoption of natural language processing with pathology reports. This is the Catalan experience. They adopted in this case, and it's quite recent, they adopted the natural language processing techniques to try to improve the archives of their pathology reports. And what they showed is that thanks to natural language processing, they were able to translate the SNOMED-CT code to the ICD oncology codes that we saw before. They were also able to translate the old SNOMED-CT coding following, for example, the release of 2015 and updating it directly with natural language processing. So in this case, it's a machine learning or deep learning technique applied on the optimization of the reports archives. And this journey arrives to our experience. As I already mentioned, we are trying to translate towards a digital pathology workflow in the Lombardy region, and we are doing it in different fronts. The pre-analytical phase, the LIS and scanner and WSI for primary diagnosis, the archives, and the optimization of the pathology reports. As you saw, the Italian society is pushing the adoption of structured reports. The structured reports with the ICCR template will be linked to the SNOMED-CT automatically in a way that the pathologist that rendered the diagnosis is already coding with SNOMED the pathology report. But what about the retrospective narrative, non-structured reports that we have in our archives? All those information would be lost if not appropriately coded, for example, and only natural language processing can help us extracting those information from those retrospective reports. That's the rationale behind the work we carried out in the last year, and we published in the Italian journal just to testify that the effort has been made for a situation that is kind of like the one that we have here in our country. Just to give you an idea, we extracted from our LIS unstructured reports diagnosis, as you can see in the first row of this column, in this column of this Excel file, and just next to them, the prevalent code, morphologically diagnosed or topography codes that are linked to this diagnosis. Just to give you some numbers, we extracted pathology reports from 2014 to 2022 that assigned to training and validation set, and we are talking about 300,000 pathology reports. And then, as a prospective test set, we adopted about 1,200 reports from 2023, from the first part of 2023, to check whether the developed mechanism of automatic coding SNOMED-CT to the narrative diagnosis was working or not in a prospective independent cohort. What we used as tools in this case are two different models. We are talking about the natural language processing methods can be machine learning based, like the super vector machine model, which is quite easy and older method with its benefit and contra. And on the other hand, we used a still quite basic, if we would say, deep learning model, which is the long short-term memory model. So two different concepts applied on the same problem to see whether one or the other was performing best. What we did, extracted the reports from our series. We cleaned the data to exclude those diagnoses that were uncoded. We excluded the diagnosis with multiple lesions in this preliminary phase. We selected the most frequent codes to remove the outliers, those really rare conditions and rare codes represented in the code that would reduce the capability of the models of stratifying. And after this cleaning of our code, we went under processing phase. The pre-processing phase was quite easy from the text point of view, because we turned it lowercase, we truncated the words in a way that we adjusted the initial part of the word independently from the terminal part, and we make the tokenization, meaning that we assign essentially to the single term value that can be understood by the support vector machine model, for example. We eliminated stop word, numbers, punctuation, everything that can be confounding from the machine learning or deep learning. And then we trained with all this data the model to classify single diagnosis to that code. And once we obtained the training of this model, we adopted the same thing on the validation set. What we found is that, unsurprisingly, in our reality, about 2%, even less, 1.4% of available codes were used by our pathologists retrospectively. Of this 1.4, 50 most frequent codes covered about 80% of the reports, meaning that if we consider 50 codes, we are almost covering the majority of our case series. And that's why we focus the attention and we trained our model on the 50 most frequent codes found in our cohort to see how it performed. And this is the statistics. As you can see, more complex deep learning models, long short-term memory, took significantly more time as compared to the support vector machine models that are machine learning easiest, with even better accuracy in the validation, but almost comparable accuracy in the test set. The performances are quite similar, as you can see in the F1 score performances in the validation set, as compared to the study that I showed you before of the Italian Institute of Tumor with the ICD codes, because the concept is almost similar. So this improved further the findings of the colleagues, but we were not completely satisfied with these results. We asked ourselves whether the models that we trained and validated were just selecting for chance, or they were assigning the code to those reports on purpose. And if there was a reason, we wanted to understand which reason was. That's why we adopted here what is called explainable AI. With the LIME library, we tried to go within the black box of support vector machine or long short-term memory models to understand which words of the narrative reports were bringing the model to select that specific code. And that's what we found, that some correct predictions were relying their code assignment to the correct words, like in this suspicion for malignancy was the suspicion for malignancy code was based on the presence of exactly those Italian, of course, words within the narrative report. The same is true for squamous cell carcinoma in situ, that was based on the presence in the narrative reports of Bowen syndrome or in situ squamous cell carcinoma within the narrative report. Sometimes we had missed prediction, like in the case of in situ versus invasive squamous cell carcinoma. But even when the prediction was missed, the differences were slight as compared to the competing predictions. And these are borderline situations in which even a single word can slightly make the model change its prediction. This of course has been a preliminary experience, has some limitations. First of all, the mainly retrospective nature, the not complete coding of our case series, because it was just based on all the reports that already had a code. Rare cases were excluded. Like I said, we excluded all that codes that were not significantly represented in our cohort. This can be addressed through the employment of zero or few shots learning approaches. We excluded multi-diagnosis or multiple diagnosis or multiple codes in a single diagnosis to simplify a little bit the model construction, but these models can be eventually developed with the multi-label and multi-class models. And this is the further step that we are starting from this moment. There is a limit. There is a limit with negation, like negative for neoplasm or negative for or inadequate. Everything that is not specific or just descriptive has some problems because it can be still reported in a heterogeneous way among pathologists. In this setting, the standardization of the report, adoption, for example, of the CCR models could improve the extractability and associability of codes with these reports. We are working on the next step. That is the adoption of what is quite trendy in this period, the adoption of the so-called transformer models. Transformer models that can be encoder or decoder models, or both. Many of you probably know the BERT model from Google, the GPT models that are quite used today. All these are natural language processing models, much more complicated than the deep learning long short-term memory that we used in our study. More potentialities. Of course, they can eventually unlock all those features that I mentioned before. The rare occasions, the rare codes, the multi-label and multi-class tasks. These are known to be employed already in pathology. As you can see, this is the ChatGPT example of diagnosis made or extraction of information from single pictures, like in the signet ring cell carcinoma diagnosed by GPT encoder towards the image of a signet ring carcinoma uploaded by a colleague. This is true for images, can be modified through input of text by the humans, and this is an example of natural language processing. Recently, this is a publication of yesterday, these transformers have been used to extract complex information from the reports, clinical and pathology reports, on which the authors construct complex models to predict the follow-up and outcome of the patient, just based on the description of the pathology report of breast cancer, for example. We are going to adopt these transformers on this SNOMED use case. And what we thought to do and what we are doing currently is trying to think of the problem, destructuring the SNOMED-CT design, because actually the final code is a combination of numbers. Each part of this code has its own meaning in terms of concept, in terms of hierarchy, attributes, identifier, description, relationships. Meaning that the final code is a combination of information encrypted into numbers. What we did so far is an example of many to one, meaning that we have many information, different words making our pathology report, and we tried to assign one single code, SNOMED code, to this main information. Probably the correct approach to further improve this automatic assignment of codes to the pathology reports is to adopt a many-to-many idea. Like, for example, this simple report of adenoma high-grade dysplasia, that in a many-to-many perspective should be that adenoma corresponds, for example, to 74, high grade corresponds to 00, and dysplasia, this is just an example, corresponds to the 3. And the final number, the final SNOMED code in this case would be 74003, corresponding to the correct severe dysplasia, but is not assigned on the whole information of the pathology report en bloc, but for each single term, we assign the correct section of the SNOMED-CT code. This partial success that we had with our model that is allowing us to recode retrospectively our pathology reports that are mainly narrative has been done and is going to be done thanks to the crosstalk among different specialists. Because if we want to improve our patient care, our knowledge of this complex digital pathology field, we have to make easy an interface with, of course, people that talk about the coding, and SNOMED part is one of these. Every day, pathologists, clinicians, biologists, and technicians that are the core working group of our pathology departments. AI engineers, computer science people, we are currently collaborating with Professor Delamea from Udine on this fascinating project of SNOMED-CT, and they give us great inputs, for example, on the transformer part. And as we were discussing before with Susie from SNOMED, the regulatory agencies, of course, it's important to make them aware of the importance of this topic, because it's a key part of our work to make everything interoperable and to improve patient care independently from where the patient is located. With this, I conclude my talk, and I would like to thank the UNIMED group. It's multidisciplinary, as I mentioned. The young people that work with us, especially Dr. Katsaniga, that is an hybrid pathologist and computer scientist, and the European Society of Digital Pathology group, that is my international family.
Vincenzo, thank you so much. That was excellent. I have to say that when I first read your paper, the fact that you found that performance and accuracy were statistically similar across, but that was only with the just the multi-lesion samples removed. And like one of my questions were going to be around that. So to see that that's going to be like some of the next steps was really exciting. But also, I have to say, my other thing was going to be like, okay, what else is next? So for you to provide that teaser about the transformer models being the next application, and then you also showing that there was, did you say that the article just got published yesterday?
That article has been published yesterday on not mine, of course. No, it's not mine article, but it's an article from another group that is applying transformers, not on the automatic coding, but on the extraction of the information from the pathology and clinical reports of oncology patients to build models to stratify their follow-up and outcome. So transformers are currently used on pathology reports, and is the frontier probably of this discipline. Of course, the main point here is the concern regarding the sensitive information that are provided to models. And it's quite big topic that does not take into account this easy, simple, let me use simple, but I'm not a computer science. The simple models that we use so far, it's not a big deal because they are mainly statistical models that work locally. The current discussion on the in the communities, whether those currently widely available, like let me do some name, ChatGPT is widely available to everyone. The employment of these are criticized for privacy purposes.
Exactly. And then even from the SNOMED-CT side, what we were finding early on when ChatGPT and everything were first coming out, you'd ask it for a SNOMED code and it just gave you a random set of numbers. It wasn't even correct. But over time, we're starting to see that some of it's actually like starting to become a little bit more accurate. So it'll be interesting to see how these improve over time. But I'll definitely check out that article. And yeah, definitely looking forward to some of your next steps with, improving the system, utilizing the multi-lesion samples and everything. The other thing when I was looking at it, so one of the hats that I wear here at SNOMED International is on the collaboration team. And we recently, 2 years ago, entered into a new collaboration agreement with the American Joint Council on Cancer. And so we updated a lot of our TNM codes. We used to have versions like 5 and 6 in there. And so we've updated to the most recent version. So I'm wondering, if as you go forward, if you'll have a little bit better results also based on just SNOMED-CT having more up-to-date morphology and topology codes just in the terminology itself.
Yeah, I didn't mention this, but we had to retrieve what you are saying is correct, and we had this already to overcome as a potential limit, because we had to retrieve reports from the 2014, and in that time we didn't have the most updated SNOMED-CT coding system, and we used to have a SNOMED 3 version of the coding
really
system.
Old.
So we had as a first step to convert SNOMED 3 codes into SNOMED-CT using always the same models. So it has been a first preliminary pre-processing step that can be already done actually with natural language processing techniques, as the Catalan experience that I should demonstrate.
Yeah, no, we'd love to have you back at maybe like the SNOMED-CT Expo to show some more about this, definitely. So I do see some questions in the Q&A box. So if you have questions, go ahead and submit. Oh, one of them went away. Just to answer out loud, so today's session is recorded, and we will also make these slides available. So I will email everyone who's registered, so you will definitely have links to all of that later. And the second question, same exact thing. So if you have any questions, we still have a couple more minutes, so go ahead and enter those into the box, the Q&A box. My other thing also, it was interesting because again, and it's because I wear the collaborations hat, I saw that you also looked at some of the mapping specifically with ICD-O and other standards. And so from SNOMED-CT, we create a lot of maps. And one of the maps that we have, it's outdated now, is a SNOMED-CT to ICD-O 3.1. And we haven't yet updated to the 3.2, but also because you haven't used the most up-to-date SNOMED-CT. But I was wondering if you utilized any of those resources that we provide in helping you provide some of those maps, or as a secondary validation for you for those maps, or something where you could feed back to us for further, I guess, quality assurance.
We know those maps. We find them useful because they are like dictionaries for this model, because they already have the information that they need to translate the current code, either as SNOMED or ICD, in the vice versa. We didn't have yet the need for doing this, because we always use SNOMED internally in our pathology report, and we didn't have the need for reverse coding them in ICD, neither the request so far, but probably this will be also requested prospectively in our reporting being double coded. So this is for sure.
I didn't
This
think
is
about
for sure one good option. Currently, the ICDO 3.1 is the one used and exposed in the
Okay.
Catalan experience that I mentioned before. I don't remember if they used directly the map, but for sure the map that you mentioned is valuable sources for helping these kind of models to
Let
learn
me know
how
if you
to
need it.
translate. Yeah, I will let you know. Thank you.
Definitely, definitely. So we have a question from an Alexander Dank. Thank you for your question. He says, any ideas on how to solve the negation issues in traditional models?
We struggled understanding this. What we faced is that traditional models, I am assuming that we are talking about the good old supervector machine or easy deep learning, because
Yeah.
I do not expect to have the same issue with transformers, or even if there is, it should be significantly reduced because are much more complex and they can integrate even rare instances. For what we understood or assumed, probably the major reason for these negation issues are the heterogeneity in which the negation is reported by different pathologists, which make one code, the negation code, let's say -4 neoplasma, corresponding to different reports that can be negative, no neoplasia, there is no neoplasia in the sample, meaning every pathologist report this in different ways. The model is not enough trained consistently at the same way to assign that code to that lemnization.
Yeah.
Transformers are a little bit more smart on this. Can understand that they can understand better than they can generalize better in small numbers of samples, meaning that even if they encounter this only a few times, they can assign it to the correct code. But I'll let you know, of course.
Yeah, exactly. Let us all know, please. I'm sitting on the edge of my seat.
I can imagine.
And yeah, we have time for one more question and it just came in. So any ideas on nuances about the data sets, populations represented, clinical practice patterns used to create the models? Nice question.
The population presented is the retrospective population and is biased a little bit because it's the population in which SNOMED-CT codes were used, meaning that probably we have, for sure, we have a subset of this retrospective population not coded at the beginning when the diagnosis was rendered. And so this excluded from our study a subset of the population that can be more or less heterogeneous. The clinical patterns could be a problem because generally, for what I saw, seeing these reports retrospectively, there were some pathologists more prone to use SNOMED-CT codes in their report. Other pathologists less prone to use it. So there is a clinical pattern, but it's not predictable for what I saw, at least for our experience. The best would be, of course, prospectively to adopt the correct SNOMED-CT to all the reports and then develop this model. And it's what we are trying to do, curing more prospectively the coding of this diagnosis and train a new transformer model on a more homogeneous, let's say, in terms of coding, subset of cases.
Yeah, but you have to start somewhere and you guys have made excellent progress. That's really exciting for sure.
Thank you.
Okay, so that wraps up. We are at the top of the hour. So I wanted to thank everyone for attending and thank you, Dr. Limperio, for presenting today. Everyone, I'm Susie Roy from SNOMED International. My email address or our general email is on the screen. And we will be emailing you the link to this recording and slides. And thank you for attending and hope to see you all soon. Thank you.